चेक करते हैं what is this intersecting chord theorem. So we have a circle with center O, and in this we have got two chords are there. One is AB, another is chord CD. They are intersecting at a point P. Then as per intersecting chord theorem, the product of PA into PB, that's the length of PA into PB, this will always be equal to the length PC into PD, irrespective how small or big the chord is. If they are two chords are cutting each other, then they will always maintain this relation, that's PA into PB is PC into PD. So here again we have got two chords, one is this blue color, another is green color, they are cutting each other. Then the product of length A into B, this will be equals to the product C into D. Let's check the proof of it. So here given is in a circle two chords AB and CD, they are intersecting each other at point P inside the circle, and we have to prove that product of PA into PB is equals to PC into PD. Construction is we'll have to join AC and BD. Let's check the proof. So in triangle PAC and PDB, so this is your PAC and the triangle PDB. So in these two triangles, the angle P, these are the vertically opposite angles are there, so they are equal to each other. Also if we'll see, this AD is a chord which was hidden, and we know that in a circle chords subtend equal angle on the same side of the segment. That means this ACD and ABD, this will be equal in length, equal in magnitude, and thus by angle similarity we can say that these two triangles are similar to each other. And if the triangles are similar to each other, then the ratio of corresponding sides, that is here we are taking PA into PA into PC, that's equals to PD into PB. If we'll cross multiply them, we'll get our required result, and this is what we are looking forward to and hence proved. I hope this theorem and its proof is crystal clear to you. We'll see you in next video. Till then, tata, bye bye.